Check, check, see if this mic works. All right, I think it's working. Section 1.1, students will be able to find average and instantaneous velocity. You are driving down the interstate when you notice you're at mile marker 100 at 1 p.m. 2 hours later, you notice you're at mile marker number 220. What was your average velocity, your average rate of change for those 2 hours of the trip? Well, you started, we're going to report this as miles per hour. So in other words, distance over time. Now, we ended at mile marker 20, started at 100, and this took 2 hours. So that's 120 over 2, so 60 miles per hour. How fast were you going at 1:34 p.m.? Well, we don't have enough information in this to be able to answer that question. Average and instantaneous speed. A moving body's average speed during the interval of time is found by dividing the distance covered by the elapsed time. The unit of measurement is length per unit time, kilometers per hour, feet per second, or whatever is appropriate to the problem at hand. Example 1. Find an average speed. A rock breaks loose from the top of a tall cliff. What is its average speed during the first 2 seconds of fall? Solution. Experiments show that a dense solid object dropped from rest to fall freely near the surface of the earth will fall this far in, let's go feet for our after t seconds. We need f of 2 minus f of 0 over 2 minus 0. So that's going to be 16 times 4 minus 0 over 2, which is 64 over 2, which is 32 feet per second. Find the instantaneous velocity of the rock at 2 seconds. Well, what we could do is we could say we're going to do the average velocity from 2 to 3 seconds, which is really the slope of the sequence. I mean, this is just slope of the secant line, because that's just slope, y2 minus y1 over x2 minus x1. We could go from 2 seconds to 3 seconds and say, well, that's the instantaneous velocity. Or we could go from 2 to 2.5, or 2 to 2.1, or 2 to 2.01. Do the average velocity for that and then call it the instantaneous velocity. But we can even do better than that. We're going to have the first point be 2, which is 2, and if we plug that in, that's going to be 64. And the second point is going to be 2 plus a little bit more. And we're going to plug in 16 times 2 plus h squared. We'll plug 2 plus h in for there. So now we got 2 points. But the second point is going to become infinitely close to the first point. And we're going to do that with a limit. So we have limit as the difference between the two, between 2 plus h and 2, as the difference becomes nothing, becomes 0. We'll do y2 minus y1 over x2 minus x1, which just becomes h, because you have 2 plus h minus 2, and those will always cancel, so it'll just be h. We have the limit as h approaches 0, 16 times 4 plus 4h plus h squared minus 64 over h. Limit as h approaches 0 of 64 plus 64h plus 16h squared minus 64 all over h. Now anything without an h better cancel, and it does. Now we can factor out an h on top. We get 64 plus 16h. Now that one cancels with the one in the denominator. We can finally plug 0 in, and we get 64 feet per second. A water balloon dropped from a window high above the ground falls y equals 4.9 t squared meters in t seconds. Find the balloon's average speed during the first 3 seconds. We need f of 3 minus f of 0 over 3 minus 0. So let's find out what 9 times 4.9 is. Whoops, I got to turn the calculator on first. Let's clear that. Let's clear 9 times 4.9, and that's 44.1. Minus 0 over 3, and we need to divide 44.1 divided by 3. And we get 14.7. That's going to be, meters per second. Letter B, speed at the instant t is equal to 3. We have the limit as h approaches 0 of 4.9 times 3 plus h squared minus 4.9 times 9, plugging 3 in. I know that's 44.1 over h. All right, now we got some algebra to do. Limit as h approaches 0 of 4.9 times 9 plus 6h plus h squared minus 44.1 over h. Limit as h approaches 0 of 44.1 plus, I need 6 times 4.9. 6 times 4.9. 29.4 h plus 4.9 h squared minus 44.1 over h. Now those 44.1s, they're going to cancel each other out, which is good because they don't have an h with them. Limit as h approaches 0 of, we're going to factor out an h, 29.4 plus 4.9 h over h. Those cancel out, plug the 0 in, get 29.4 meters per second. Use graphs and tables to find the limit as x approaches infinity and negative infinity, then identify all horizontal asymptotes. Let me set this up so that I can use the calculator and leave it up there. There we go. We're going to go sine of 2x and divided by x. Let's go zoom 6. And we're looking at infinity and negative infinity, and those are leveling out to 0. So A is 0, B is 0, identifying horizontal asymptotes. Well, yeah, y equals 0. The next one, let's clear that out. 3x squared, 3x to the third, minus x plus 1 divided by x plus 3. And we're going to graph this. And it looks like the limit as x approaches infinity is infinity, and it's true. But B looks like it's negative infinity, but we're not seeing the entire graph. If we zoom out, we need to look on the left side of that vertical asymptote, which is at negative 3. Still didn't zoom out enough. How about zoom? Is there there's usually like a zoom fit. There we go. Let's zoom fit. And we can see that there's the other side of the vertical asymptote, and we can see that it's going up to infinity. So C is none. Now, another way to do this is for infinity, these don't matter. The only thing that matters is this right here. Now, that reduces to 3x squared. 3x squared looks like that. So on the ends, it's going up on both sides, up to infinity. Find the limit and confirm your answer using the squeeze theorem. The highest value for cosine is 1, and 1 minus 1 is 0. And the lowest value for cosine is negative 1, and 1 minus negative 1 is 2. So I know that this function is going to be between 0 and 2 over x squared. So 1 minus cosine x over x squared less than or equal to 2 over x squared. So we're going to take the limit as x approaches negative infinity for all three of these. Well, this is 0. This is 0. And so by the squeeze theorem, the limit as x approaches negative infinity of 1 minus cosine of x over x squared goes to 0. Use graphs and tables to find the limits. So let's use graphs and tables here. We have x divided by x minus 2. And we want values that are very close to the left of the vertical asymptote, to the left of 2. Well, if we graph this, I should probably use the standard window. I'll wait till this finishes. Zoom 6. We see to the left of 2, this is going down to negative infinity. Now, if you plug a value to the left of 2, let's say 1.999, that's going to be 1.999 minus 2, which is 1.999 over 0.001, negative 0.001. So when we divide a number by a very small number, it's getting very large. This value is getting very large, but it's negative. So that's how you can get negative infinity. So now if we apply that same rule to, let's say, the second one, I want to show you something else too on this. If you go to table set and have it ask what values it wants to evaluate, then when you go to the table, you see I already have some values in here. If you go to, let's say, 1.999, we can see that it's a very large negative number, meaning as it gets closer to 2 on the left side, it's getting very negative. Let's go x over x plus 3, and we're going to use a table to find out what's happening on the right side of negative 3. What's on the right side of negative 3? Negative 2.999. And that's going down to negative infinity also. If I look at the graph, on the right side of negative 3, it's going down to negative infinity. So this one is also approaching negative infinity. Find the limit as x approaches infinity and negative infinity. Well, it doesn't matter on this one, and that's going to be 0. So 22, 0 plus 1, and then since that's tied, the powers are the same, that's going to go to 5 on both sides. So both answers are 5. For number 24, we have 2x over x plus sine of x over x. Those cancel out, so it's 2 plus 0 when you do the limit. So 2 is the answer. The distance a particle travels is modeled by the function in feet after t seconds. Find the average velocity for t equals 1 to 3 seconds. We need f of 3 minus f of 1 over 3 minus 1. We have 2 times 9 minus 9 when we plug 3 in, minus 2 minus 3 when we plug 1 in. That's over 2. So 18 minus 9 is 9, plus 1 is 10. 10 over 2 is 5. How fast is a particle traveling at t equals 2 seconds? Limit, as h approaches 0, of 2 times 2 plus h squared minus 3 times 2 plus h minus 2 times 4 minus 6 all over h. So we have the limit as h approaches 0 of 2 times 4 plus 4h plus h squared minus 6 minus 3h minus 2 all over h. Limit as h approaches 0 of 8 plus 8h plus 2h squared minus 6 minus 3h minus 2 all over h. Well, 8 minus 6 is 2, minus 2 is 0, 8 minus 3 is 5h. So we can factor out an h, and that'll be 5 plus 2h over h. Those cancel, plug in the 0, 5 feet per second.